Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve payload questions from key periods. Previously, we solved many questions, at least 80 questions. I hope you have been practicing them and finding them easy. In this video lecture, we are going to solve next questions. So let's begin with question number 81. An aircraft has 4 engines, each of which consumes an average of 1000 kg fuel every hour. What traffic load can be carried if the duration of flight is 3 hours? Then they have given you other conditions: maximum takeoff mass, performance takeoff mass, ram fuel, startup and taxi fuel, landing mass, performance and structural, ram fuel, variable loads, DOM, zero fuel mass, basic empty mass. Okay. So again, we will start with a step number 1, which is to make 3 columns, one for one for takeoff mass, the second one for landing mass, and the third one for zero fuel mass. In the takeoff mass column, you write the value which is less of performance limited takeoff mass and maximum structural takeoff mass. In the landing mass column, you write the value which is the less of performance limited landing mass and structural limited landing mass. You add trip fuel to that value. In the zero fuel mass, you use the formula zero fuel mass plus fuel on board. Okay. Now, between performance limited takeoff mass and maximum structural takeoff mass, performance limited takeoff mass is less, which is 68,000 kg, whereas maximum takeoff mass is 69,500 kg. So we'll write 68 here. Next, between performance limited landing mass and structural landing mass, performance limited landing mass is less. So we'll write 57 here. Add trip fuel to this. Now, trip fuel is not given to us directly, but they have given us some other piece of information, as in 4 engines of aircraft. Every engine consume 1000 kilogram fuel every hour. So there are 4 engines: engine number 1, engine number 2, engine number 3, and engine number 4. Every engine consumes 1000 kilogram per hour. Now this is a 3-hour duration flight. So flight duration is 3 hours. So that means for 3 hours, this one engine will consume 3000 kilograms for 3 hours, right? 1 hour consumes 1000 kilograms. For a 3-hour duration flight, the same engine will consume 3000 kilogram of fuel. Likewise, engine 2 will also consume 3000 kilogram fuel for 3-hour duration. Engine number 3 will do the same, 3000 kilogram fuel for 3-hour duration. Engine number 4 will also consume 3000 kilogram fuel for 3-hour duration. Now, total fuel consumed by all the engines for this 3-hour duration flight is equal to trip fuel equal to 4 engines multiplied by 3000 kilogram. So 4 3s are 12, which is 12,000 kilogram. So 12,000 kilogram is the total trip fuel required for this 3-hour duration flight. So we add 12 here. Okay. Now 57 plus 12 is 69. Next, zero fuel mass. Zero fuel mass is 45. Fuel on board or takeoff fuel is, now it's not given to us directly, but we know fuel on board, also known as takeoff fuel, fuel in the fuel tanks when airplane is on the runway, is nothing but your ram fuel minus startup and taxi fuel. Now ram fuel is 25,778. Startup and taxi fuel is 350 kilogram per engine. There are 4 engines, so 350 into 4 will be equal to 1400. So you subtract 1400. So 25,778 minus 1,400 is 24,378. So you write 24.378 here. So 45 plus 24.378 is equal to 69.378. Now out of these three takeoff values, we have to go ahead with that value, which is the least of them all. And that value, as you can see, is 68. So this becomes a regulated takeoff mass. So regulated takeoff mass equals to dry operating mass plus payload or traffic load plus takeoff fuel or fuel on board. Regulated takeoff mass equals to 68. Dry operating mass is 26,372. Takeoff fuel is 24,378 and payload. Therefore, payload will be equal to 68 minus 26.372 plus 24.378, which is 50.75. 68 minus 50.75 is 17.25 or 17,250 kg. So you can carry 17,250 kg of payload on this 3-hour flight. Option Charlie is the correct option. Okay. So this is how you do this sum. Let's go to next question. Question 82. Aircraft has a basic empty mass, dry operating mass. How much traffic load can be carried on a flight for which takeoff fuel load is so and so and maximum allowable takeoff mass is so and so. So this is a direct formula based question. Write the formula. Maximum takeoff mass equals to dry operating mass plus fuel on board plus payload. Now maximum takeoff mass is 175. So write 175 here. Dry operating mass is 125. Fuel on board is 22 plus payload or traffic load. Therefore, payload equals to 175 minus 147. Okay. So 175 minus 147 is 28 or 28,000 kg. Okay. So correct answer is option delta 28,000 pound in this case. So simple direct formula based question. Question 83. A cargo aircraft has a basic empty mass given to you and is fitted with special equipment weighing 9,500 pounds. How much traffic load can be carried on this flight with takeoff fuel load of 22,000 pounds and three crew, that is three pilots, of average mass 195 pounds if maximum allowable takeoff mass is so and so. Again, direct formula based question. So what is your dry operating mass? It's not given to you directly. But we do know that dry operating mass equals to basic empty mass plus variable loads. Now in this variable loads, one considers special equipment and crew, right? So plus variable loads. What we mean by variable loads is special equipment plus crew, the weight of crew. So let's write this here. So basic empty mass is, so in place of DOM, we write basic empty mass plus special equipment plus weight of the crew plus fuel on board plus payload. So basic empty mass is 170, correction, basic empty mass is 115, special equipment is 9500, so 9.5, cargo is, correction, crew is, there are 3 pilots, each weighing 195 pounds. So 3 of them will weigh 3 into 195, which is 585 pounds, right? So add 585 now. So now this entire addition is your DOM. It's nothing but your dry operating mass. Going ahead, fuel on board is 22,000 pounds, so 22 plus payload. Takeoff mass is 175. Therefore, payload will be equal to 175 minus 115 plus 9.5 plus 585 plus 22, which is 115. So this is 0.585. Okay. Cargo is 0.585 divided by 1000. So 115 plus 9.5 plus 0.585 plus 22 is 147.085, which is equal to 27.915. Okay, so answer will be 27.915 is nothing but 27,915 pounds. Remember this. Next, question 84. Similar question. Aircraft has 4 engines, each of which consumes 1000 kilogram fuel every hour. And this is a 3-hour flight. Okay, and then they have given you different conditions of the flight. So again we start with a step 1, where we make 3 columns, and in each column we write different takeoff values. The first column we have to write a value between value which is lower of performance limited takeoff mass and structural takeoff mass. Performance takeoff mass is 60,000, structural one is 69,500. Between them 60,000 is the lesser value, so I write 60 here. In the landing mass column you write a value which is less of performance landing mass and structural landing mass. So performance landing mass is less than structural, so write 50 here. Add trip fuel to that. Trip fuel is not given to us directly. They have told us that there are 4 engines on this aircraft, wherein each engine consumes 1000 kg fuel every hour. This is a 3-hour duration flight. So for total 3 hours of trip time, this engine number 1 alone will consume 3000 kilogram fuel. Likewise, engine 2 will also consume 3000 kilogram for next 3 hours. Engine 3 will consume same fuel for 3 hours. Engine 4 will also consume the same fuel for next 3 hours. Total trip fuel will be equal to 3000 plus 3000 plus 3000 plus 3000. That means 3000 into 4, or which is equal to 12,000 kilogram fuel. So all 4 engines will consume 12,000 kilogram trip fuel for your entire trip time, for your trip of 3-hour flight. So add 12 here. 50 plus 12 you get 62. Next, zero fuel mass. 51,500. Fuel on board. Again, it's not given to us directly. They have given us maximum ram fuel, startup taxi fuel, and ram fuel. So to know or to calculate fuel on board, you do this subtraction, ram fuel minus startup and taxi fuel. Rank fuel is 25,778. Startup taxi fuel is 350 kg per engine. So for 4 engines, it will be equal to 1,400. So 25,778 minus 1,400 is 24,378. So add 24.378 here. So 51.5 plus 24.378 is 75.878. Out of this three takeoff values, you select that value which is the lowest of them all, which is 60. And this becomes your regulated takeoff mass. Now regulated takeoff mass is equal to payload plus fuel on board plus dry operating mass. Now regulated takeoff mass is 60, payload you don't know, fuel on board is 24.378, dry operating mass is 26.395. Therefore, payload will be equal to 60 minus 24.378 plus 26.395, 50.773. That is equal to 9.227. Okay. So payload that you can carry on this flight is 9,227 pound or 9,227 kilogram. Next question 85. Formula based question. Basic empty mass is given to you. Special equipment weight. Okay. Then 4 pilots each weighing 195 pound. Takeoff fuel load of fuel on board is there. And maximum takeoff mass is also here. So let's substitute the values. We know the formula regulated takeoff mass is DOM plus payload plus fuel on board. DOM is nothing but basic empty mass plus variable load. Under variable load, we are talking about 7,500 of special equipment and 4 pilots each weighing 195. So 7.5 plus 4 into 195 is 780. So 0.78 plus payload plus fuel on board 19,500. So 19.5. Takeoff mass is 1,90,000, so 190. Therefore, payload will be equal to 190 minus 7.5 plus 0.78, 19.5, which is 27.78. And I forgot to add basic empty mass, which is 100. So this is actually 127.78. 190 minus 127.78, 62.22. 62.2, yeah, or 62,220 pound of payload. So 62,220, option Charlie. So this is how you do all the 5 questions. Practice them on your own without looking. And in the next video lecture, we will do next 5 questions. So don't miss the next video lecture. Be available. And I request you all to like this video lecture, subscribe to this channel, and share this video with all your friends. See you next time.